Assalamualaikum. My name is Muhammad KHAIRI AIMAN. Today I will present our group project by Vortex, which is reverse engineering and CAD modeling of a portable plastic hand fan. So let's begin our presentation. There are our team member. Our group consists of 5 members. Each member was responsible for different tasks, including measure the product, creating CAD model, assembly the part, and prepare the report and presentation. Our product is portable plastic hand fan. It is more rechargeable fan that provide cooling by using a DC motor to rotate the fan blade. We selected this product because it has several mechanical components that are suitable for reverse engineering and SolidWorks modeling. This project also helped us improve our CAD modeling and assembly skill. This project has 3 main objectives. First, to develop accurate 3D CAD model using SolidWorks. Second, to assemble all the individual components into one complete product. Third, to perform structure analysis on the critical component to evaluate their strength and safety. This slide shows the workflow of our project. First, we identify the problem and study the existing product. Next, we measure all the components and create the 3D CAD model in SolidWorks. After that, we assemble the component together. Finally, we perform structure analysis and make improvement to complete the final product. This slide shows the first 2 CAD components. The first component is electric motor, which provide the rotational motion for the fan blade. Second component is a motor bracket, which hold the motor secure inside the fan housing. This slide shows 3 components. The back housing protect the internal component. The front housing is connected to the back housing formed to the fan body. The fan blade rotate the generate airflow and provide cooling. All of this part we modeled according to dimension of the original product. This slide shows another 3 components. The battery supply electric power to the fan. The charging port is used to recharge the battery. The button cap is the external button used to operate the fan. This slide shows the final 3 components. The front fan guard protect the user from the rotating fan blade. The button handle provide the comfortable grip when holding the fan. The push button switch control the fan operation by turning it on or off. This component, the 11 component. This complete the 11 component used in our CAD model. That's all for my presentation. Now I would like to invite to my teammate to continue with the next part of the presentation. Thank you.
Hi and Assalamualaikum. My name is MIRA and I will be presenting the technical drawing. Moving on to our technical drawing, this showcases the detailed engineering drawing of our motor bracket. Here we establish basic, critical and reference dimension using digital calipers to ensure exact real-world modeling accuracy. In this technical drawing, we have many type of view. There is top view, ISO view, custom ISO view, left view, right view and bottom view. There is also a slice section. Similarly, this detail the back housing component. Here we capture the key structural parameters utilizing slice and cross-sectional views. To carefully model the interior alignment slot, we have the dimension accuracy for basic dimension and reference dimension. Next, this slide highlights the front fan guard. For precise measurement of the outer diameter and critical thickness was required here to guarantee that the snap fits match the physical counterpart perfectly. Here are the basic dimension and the critical dimension for the front fan guard. Next, we are moving on to the assembly and the exploded view. For the final assembly, all individual CAD components were integrated within SolidWorks by utilizing precise coincident, concentrate, and the distant mix. We ensured zero part interference, perfectly mirroring the original product. This is the photorealistic isometric view of our completed digital assembly and contrasted directly against the actual physical hand fan we reverse engineered. Here we have the standard front right orthographic view, confirming the proper geometric alignment and seamless external matching and the shell enclosure. These are the back left view further demonstrate the high-fidelity representation of the intake grill and the structural side profiles. These are the exploded view. This exploded view illustrates our product overall assembly sequence, showing how the internal motor, battery, and electronic switches layer cleanly into the housing. Next, we will move to the video that we prepared.
Don't nobody else make me feel like. Don't nobody else make me feel like. Don't nobody else make me feel like. Don't nobody else make me feel.
My name is REDZUAN. Now I will explain about the product rendering. Product rendering is the process of creating a high quality, photorealistic 3D image of a product using CAD software such as SolidWorks, Keyshot, Blender or Autodesk Inventor. The purpose is to make the 3D model look like a real manufactured product by applying realistic materials, lighting, shadows, reflection and camera angles. So this is the example of our handheld minifan product rendering. So next, we go to material selection. For electric motor, we use aluminium alloy 6061. It provides rigidity for motor housing while keeping the product lightweight under continuous operations. Next, for motor bracket, we use plastic PP copolymer. It supports the motor securely, easy to manufacture via injection molding at low cost. Next, for back housing, we use plastic PP copolymer. It forms the outer shell durable enough for daily handling with good aesthetic finish. For fan blades, we use plastic nylon 101. It withstands continuous cyclic rotation, lightweight, enough to reduce motor load during operation. For battery, we use plastic PF. Its direct contact with power source requires thermal stability and excellent electrical insulation. Next, for charging port, we use plastic PF also. It withstands repeated plug-in cycles, chemically resistant and electrically safe. Next, for front housing, we use plastic PP copolymer. It forms the outer front shell, protects internal components while maintaining lightweight design. For button cap, we use plastic ABS. It's consumer-facing component requiring smooth, aesthetically pleasing and durable finish. We continue for front fan guard. We use plastic ABS also. It protects user from direct blade contact, maintains airflow without obstruction. For bottom handle, we use plastic PP copolymer. It provides ergonomic grip, durable for repeated daily handling. And lastly, for push button switch, we use plastic PTFE. It ensures reliable long-term switching performance, excellent insulation for electrical safety. Next, I will continue for the cost of our product. For electric motor, it costs RM3.50. For motor bracket, costs RM1.20. For back housing, costs RM1.80. For fan blades, costs RM1.50. For battery, it costs RM2.80. For charging port, it costs RM1.01. For front housing, it costs RM1.60. For button cap, it only costs 50 cents. For front fan guard, it costs 80 cents. For bottom handle, it costs 70 cents. For push button switch, it costs 60 cents. For the additional cost like assembly and wiring fastener, for assembly it costs RM7 and for wiring it costs RM1.90. So the total estimate cost is RM25. I will pass to the next person. Thank you.
Assalamualaikum warahmatullahi wabarakatuh. My name is AFANDI ADHA bin AZMAN. So now I want to continue the presentation for structural analysis. So the structural analysis and mechanical integrity of the fan blade was evaluated using SolidWorks simulation through finite element analysis. static structural analysis was performed to determine the stress distribution, displacement, strain and factor of safety of the fan blade under the applied loading condition. So, for our group to make the justification of material we choose is the fan blade component was assigned nylon 101 as the engineering material. Nylon 101 was selected because it provides good mechanical strength, lightweight properties, excellent war resistance, and high durability, making it suitable for rotating components such as miniature fan blade. Justification of restraint fixture. A fit geometry fixture was applied to the inner cylindrical surface of the fan blade hub. This presents the actual condition where the fan blade is securely attached to the motor shaft, preventing rigid motion during simulation. And lastly, justification of loading condition. A rotational loading of 314 radian per second was applied to the hub of the fan blade to simulate the rotational motion generated by the electric motor during operation. So, this is the figure stress for structural analysis, figure displacement, figure strain, figure factor of safety, and this is the evaluation of fair result. So, for the next slide, the fair result indicate that the maximum von Mises stress occurs at the blade root due to the transfer of rotational loading, while the maximum displacement occurs at the blade tip. The displacement is very small, demonstrating that the fan blade has sufficient structural stiffness during operation. In addition, the maximum equivalent strength remains within the material elastic region, indicating that the blade does not undergo permanent deformation. Since the maximum stress is well below the material yield strength, the calculated factor of safety of 58.87 is significantly higher than the minimum acceptable value. Therefore, the fan blade is structurally safe and capable of operating reliably under the applied loading condition without yielding or failure.
Hi and Assalamualaikum. I'm DAYANGKU NURFARHANI ADRIANA binti BASRI. Next, I will present about our product innovation. For our product innovation, we focus on improving both the functionality and user experience of the handheld minifan. Instead of changing the overall design, we made several practical improvements. The front grille was redesigned to allow better airflow while still protecting the user from the rotating blades. We also modified the handle to make it more comfortable to hold, especially during longer periods of use. In addition, the battery compartment was redesigned so replacing the batteries becomes quicker and more convenient. Finally, we reorganized the internal components to make better use of the available space. This helps simplify the assembly process and improves the alignment of the internal parts. Next, for the discussion, although the simulation showed that our design is already safe, there are still opportunities to improve it further. Since the highest stress is concentrated near the blade root, increasing the fillet radius can help distribute the stress more evenly and improve durability. The blade can also be made more efficient by optimizing its thickness, which reduces unnecessary material without affecting its structural performance. Another improvement is refining the mesh around critical regions during the simulation. This provides more accurate results and gives greater confidence in analysis. From a sustainability perspective, we can improve the blade shape to achieve better airflow with lower power consumption. We can also consider using recycled or bio-based nylon materials and adopt additive manufacturing to reduce material waste while maintaining the required strength. To conclude, this project successfully met all of the objectives that we set at the beginning. Through reverse engineering, We produced a complete 3D model and assembly of the handheld minifan using SolidWorks, followed by structural analysis using finite element analysis. The simulation confirmed that the fan blade performed safely under the applied operating conditions, with very low stress and deformation, as well as high factor of safety. Overall, this project allowed us to strengthen our technical skills in CAD, modeling, engineering analysis, teamwork, and problem solving, while gaining practical experience in designing and evaluating an engineering product. That's all from me. Thank you.